Hey guys, I'm going to go over the review for the test tomorrow. This is going to be one of those where I talk more than I write because I want you to do this mostly on your own. Okay. It's the best way to get you prepared. All right. So, what is impulse? What is momentum? Those are in your notes. I'm not going to go over that. Look at your notes, Google it. You got this. Okay. What is an elastic collision? All right, I'll help you with the definition, but you can find the equation on your own because, again, those are in the notes. Elastic collisions are when things like come together first and then they bounce off of each other. Okay, so come together, then bounce off. All right, and it doesn't always have to be opposite directions. You can have a stationary object and a moving object. The moving object can hit the stationary and then they switch places essentially, or maybe this one's still going but at a slower pace. Okay. Um, Elastic is when they're not together, come together, and then go back apart. Okay. Again, you got the equation. Inelastic is when two things come together and then stay together. Okay. And then recoil is when they start together and then go apart. Okay. So elastic is kind of like both these together. Inelastic is together, recoil is apart. Okay. Again, you can find the equations on your own. Number 6, when object should say, I apologize, there's errors on this. Object A is large and collides with object B. The two objects become stuck together. How does the change in momentum of object A compare with the change in momentum of object B? All right. Change of momentum is equal to change of momentum of one object is equal to the change of momentum of another object. So even though they're large and small, okay, the change of the momentum is going to be the same, okay? And when it says that it's stuck together, which kind of collision did we say gets stuck together in the end? All right, so that's what B is. Number 7, how could a train engine, okay, how could a train engine that's 2,000 kilograms and a motorcycle that's 136 kilograms have the same momentum? Okay, they can have the same momentum. So we know that momentum is, okay, so P is momentum and it's mass times velocity. So how can object A have the same momentum as object B? Okay, well, if they're going to have the same momentum, then it's going to look like this. Okay, this is the train. It's a really large mass. This is the motorcycle. It's a really small mass. So in order for them to have the same momentum, the train would have to have a very small velocity and the motorcycle would have to have a very large velocity. So a big train moving slow and a small motorcycle moving fast will ideally have the same momentum. Okay, that's what this is talking about. So don't write this, write out what I just said in your own words. Okay, number 8, if the velocity of an object is decreased by half, what happens to the momentum? Okay, so again, momentum is mass times velocity. Okay, so if we had both of those as 1, 1 times 1 is equal to 1. Okay, but now we have the velocity decreased by 1/2. Okay, so 1 times 1/2 is going to be 1/2, so it's decreased by half. Okay, so velocity decreases by half, the momentum also decreases by half. If the velocity, I don't know, quadruples, then the speed's gonna, or then the momentum's gonna quadruple. Okay, whatever happens to the velocity is the same thing that happens to the momentum. For each situation, identify the type of collision. All right, a cat launches itself from the branch of the tree. So a cat's sitting on the tree, so it's starting on the branch. and then it jumps off. Okay, so the movement is just going in one direction. All right. B, a marble is thrown into a lump of clay and it sticks, so two things sticking together. C, a soccer player's foot collides with the ball when a penalty kick is taken. All right, so the ball starts off resting, the foot comes in and kicks it, and then the ball takes off and the foot stays behind. Okay, so two different movements on that. All right, you can identify those. Okay, here's some math problems. These are like math problems that you're going to be seeing tomorrow. Okay. Let's see, number 10. A 0.05 kilogram bullet is fired from a gun at 400 meters per second into a stationary block of wood. The bullet remains stuck inside the wood and they move off together at 12 meters per second. Calculate the mass of the block of wood. Before you can calculate, you need to know what kind of collision it is because there's three different types of collisions that we've talked about and there's three different equations. Okay, so this says the bullet, see, the bullet remains stuck inside, so it's two things coming together. Okay, so this is inelastic. All right, the equation for inelastic is mass of object A times the initial velocity of object A plus the mass of object B times the initial velocity of object B. And that's equal to the mass of A plus the mass of B times the final velocity of A and B together. Okay, so you're going to use this equation to solve it. Let's see, I'll go ahead and get let's see, so object A was the bullet, which was 0.05 times a velocity of 400 plus object B, which we don't know, but its initial velocity is 0 because it's stationary. Okay, so anything times 0 is going to be marked out. And then it's equal to the mass of A, so 0.05, plus the mass of B, which we're looking for, so I'm just going to write X. And then the final velocity is 12. Okay, so again, this canceled out. That leaves us with this is equal to this right here. You can solve for the rest. If you do it correctly, your answer should be a number 1.62 kilograms. Okay, again, I did not solve this. You need to finish solving this right here and make sure you get the same answer as me. Okay. Number 11, this should say, again, I'm sorry, I'm not perfect, never claim to be perfect, won't ever be perfect. Okay, that should say 1,000 kilogram per hour, not 1,00. That makes sense. Okay, traveling at 5 meters per second, collides into a 1,200 kilogram car traveling in the same direction at 2 meters per second. Okay, so car A is traveling fast at 5 meters per second. Car B is traveling slow at 2 meters per second. Let's see, the first car, so this car is going to bump into the second car. Okay, and when it does that, this car stops and the second car continues going. Okay, so they're hitting and then going different speeds. Okay, so of the three types of collisions, this one should be elastic, and the elastic is mass of object A times velocity of object A plus mass of object B times the initial velocity of object B, that should be initial velocity, is equal to mass of object A times the final velocity of object A plus mass of object B times the final velocity of object B. Okay, remember that it says that the first object comes to a rest, so the final velocity of the first object is 0. I'm gonna let you plug everything else in. If you do this correctly, you should be getting 4.17 meters per second. Okay, plug in the numbers, write it all down so we can see all of your work. Make sure you get the right answer. Okay. Number 12, a 57-kilogram basketball player jumps vertically upward to make a shot. At the very top of her jump, she throws the basketball in a horizontal direction with a speed of 4.4 meters per second. What is her recoil velocity immediately after she releases the ball? All right. So two things. One, it says what is the recoil velocity? So that automatically tells you you're going to be using the recoil equation. Okay, the recoil equation is mass of object A times velocity of object A is going to be matching the mass of object B times the velocity of object B. Okay. Yeah, it gives you all the information that you need. You're going to be solving for the velocity of object A. Note with recoil, okay, this is moving in the positive 4.4 meters per second. So it's moving this way, but when you shoot the basketball, you're pushing yourself backwards. So this is going, that's why she's traveling in the opposite direction of the ball. So your answer should be negative. So when you plug this all in, it's going to give you a positive number, but you have to know that ball's going one direction, she's going the other. And so your answer is going to be negative 0.048 meters per second. Okay, and that's super slow, but think about it. Tiny basketball, big human. Okay, so the ball is going to shoot off in one direction fast. The human's going to be barely affected by it, but there is a little bit of effect. Okay, so hopefully this helps you with the review. Make sure you're comfortable with it, and you guys are going to rock the test tomorrow. Okay, have a good night.